All right. Good evening. Thanks everyone for coming. Happy spring. Finally, winter is over. I'm very happy with the spring. I want to take a few moments to thank our sponsors, Bank of New York Mellon, for having us, for providing the space. Andrews, providing the pizza. Andrews, you want to come up and say a few words?
Yes.
Thanks, Andrew. Everyone, if you're eating or drinking, thank this is man.
Hi everyone, thanks for coming tonight. My name is Andrews, and I'm a Java developer, even though I run my own business and started as a company to support an open source project, a Java open source project. And even though we've grown quite a bit and we have, like, I don't know, we cover the entire technology spectrum, full software development lifecycle, I'm still programming in Java. So like I have like another, I don't know, maybe 4 or 5 open source projects that I'm working on. My GitHub is evergreen. So I'm gonna use this like few minutes to maybe introduce this open source projects. So the first one that kind of started it all is Apache Cayenne. And this is an all-around technology, so it started from approximately the same time as Hibernate, but we are doing things a little different, but we are working in the same space. So HTTP and Hibernate is doing things a little differently. Another project is called Boutique, and it is Boutique.io with double O, and it works in the same space as Spring Boot. And when we, again, the history of the project, when we started evaluating Spring Boot back in the day, I don't know, we were really unhappy with the approach of too many annotations, too much management, the slow startup time. So we sort of decided to address that, simplify the stack, and provide this, hopefully more convenient and lightweight technology to write Java applications. And do you need a microphone? All right.
Okay, so I guess everybody online, they didn't hear. Yeah, nobody else heard. Okay, but I'll continue. So that was Boutique, and yet another project is called Agrest. And how many of you are familiar with GraphQL? Okay, almost, yeah, more than half. And this was the same idea, and it also launched maybe like, I don't know, 6 months before Facebook launched GraphQL. But the idea was that instead of inventing the entire protocol to just do this like graph navigation when you're a client and you're requesting some data from the server, the idea was to keep REST as the main communication medium. So you'd use the same REST verbs like get, put, post, delete, and so on. But you can still work with as much or as little data as you want. So you have the dynamic endpoint, and as a client, you can navigate a graph. This project is active, and it's we keep doing releases. It's actually I like it a lot for web services. And finally, the final project is called dflib, and I call it like a missing data structure in Java. And the data structure is a data frame. So it's this two-dimensional table to represent the data, to do in memory data transformation similar to what you would normally do in SQL, for instance. And of course, there's lots of things that are on the big data side that are doing that, like Spark, Flink, and so on and so forth. But this is just a lightweight data structure, so you would use it as you would use a list or a map. That's just a lightweight thing. So these are our open source projects, and I hope you enjoy the presentation tonight. Yeah, I guess I need to slide with all that.
You can email to our mailing list.
Okay. Yeah. I'll do it tonight. All right.
Great.
Thank you.
Oh. Yeah. All right. Thank you. Yesterday, Java 22 was released. So they said if you're not on Java 22, you are a dinosaur. Who is on Java 17 or 21? 21, I feel 21. Who is Java 11? Older than Java 11. Why? The question is why?
Yeah.
Third party.
Third party. I think that happens a lot. All right. Small survey. We were discussing the time to start the events at 6:30 or 6. Which one do you prefer? Hands up, 6 p.m. Wow.
Depending where.
6:30. Okay, I'll just shut up. I thought that people would prefer 6 p.m., that they would leave work earlier and come to work, but yeah, I was wrong. That's totally fine. Who here is the first time joining the judge? First time? 1, 2. Show hands. How did you hear? How did you hear about the event, the Java user group? Shame on you, but thanks. But thanks for coming.
Yeah.
All right. Thanks everyone for joining. Just a couple more things. Our friends from DevNexus, you have the page there. Here, anyone have been to DevNexus, the large Java conference in Atlanta? 1, 2, 3, 4. Right. So it's probably the biggest Java conference in the US. I think last year was about 3,000 people. It's gonna happen in Atlanta on the 20th. It's April 9 to 11, I think.
Yeah, right.
They send us discount. As soon as Frank stops fighting the computer, he's gonna put the discount code here. We also have the conference, Jamil. It's an AI conference. You want to say a couple of words?
Hi, everyone. My name is Jamil. I've been friends with Frank for more than 20 years. We used to work at Lehman Brothers together. We used to wear suits every day. We are clearly, we're clearly still rebelling. He and I are still rebelling in apparel-wise. I've been involved with the SIG for a long time. I've been a member for a long time. I used to work before Lehman, I used to work at Sun Microsystems, building some of the Java pieces. But right now I run an AI community in New York City. It's called AI NYC. We're about 8,000 people, 9,000 people. We do a bunch of events in New York and in DC. Last year we did an event on the combination of AI and generative finance. We're doing one in DC in a few weeks. That's going to be held during the week of the IMF spring meeting. So you're going to have all these dignitaries and leaders and coming into town. So if you go to dcsummit.org, you can see the agenda there. We've got like BlackRock, a couple other banks there. We'd love to get BNY Mellon if somebody's here from that group who wants to come down there and speak. And then we'll do another AI and finance one later in the year in New York City. The last one I did have Frank involved with that. So anyhow, if you'd like to collaborate, if you want more information about the event, dcsummit.org, or just ask me afterwards. Thank you.
Good. All right. There's 2 more things. April 2nd, we're going to have the next event. It's going to happen here as well. Venkat Subramanian is going to be talking about asynchronous programming with virtual threads. That should be a very good event.
Tuesday.
What else? And if you stay until the end, we're going to have a raffle with JetBrains products. So thanks JetBrains as well. There is a license for any of the JetBrains products valid for 1 year. Right, without further ado, introduce Frank. I think no need to introduce Frank. Everybody knows Frank has been running this Java user group for 27 years.
Too long.
First Java user group ever created, so thanks to Frank for that. Very hot topic, generative AI for Java developers. I think everyone is curious about AI and how we can use it. So thank you, Frank.
Thanks.
Stage is yours.
Rodrigo. Thank you. And I did start this group
because somebody on the West Coast said there weren't any real programmers in New York. So I got really ticked off by that statement. So that's why I really started the group. Okay, so thanks for all of you to come here in person, and thanks for people who aren't here but they unregistered. Thank you, being polite, so you can get an accurate count for the pizza. So tonight we're going to talk about generative AI for Java developers. Now, last year I was playing around with ChatGPT and the API, so I did a little talk. It was exactly a year ago, actually last March. And I've done a lot of work since then in the API and other stuff. So I want to sort of give you what I've learned, and I'll give it to you from like this high level without kind of drilling, because this is really part of a longer course. But I want to give you some from the high level so you understand the basic concepts. Because when you go to a website and you want to learn about machine learning, you have to know Python. So you have to know Python. It's like you see all these like, oh, that's pretty cool. That little one-liner here, one-liner there to import this, that. Pretty easy. So I got little, you want to see one line of code. So I wanted to see something like this. I thought I did. All right, we're going to take time out. Talk amongst yourselves. I want to say this over again. Okay. There's the share screen thing here. I might need a little help here, Barry.
If I can do something. AI was easier than screen sharing.
It is. Where is my Zoom? You see screen share?
Oh, we need the Zoom app.
The Zoom app.
There it is, right there. Click on that, double click or whatever. Why didn't it come up?
Good question. Yes, I am. That's the Zoom app right here.
Back to meeting.
Right.
And now.
Okay.
Your screen and whatever you want to share.
This guy. Yeah. Okay.
All right.
It's up here. Anyway.
Your screen.
What's that, Barry?
Nothing, don't worry.
I gotta find my. Like I'm the only one that has that problem. Okay. Sorry, the people of the interwebs. Sorry about that. People of the future that are watching this recording. Hope you enjoy your flying cars and President Taylor Swift. Okay, where was I? So I wanted to have code like this as a Java developer because I saw all these really short Python snippets for doing machine learning. So I wanted to get to this. This was my goal. So I could stop right here. I said, "There's the API," and I can say, "Good night. Thank you very much. I'm done." So that's where I got to. That's how easy it is. It's extremely easy. But I want to tell you how I learned all this stuff. It took a little bit. And to do generative AI properly, it's not just the Java API you just use. You have to take a step back. You have to understand a little bit about what it is. What is generative AI? What are the terms? Because the way it's portrayed in the press is just wrong. It's just, it's the press, right? So, you watch 60 Minutes and, a program's telling me to leave my wife. I was like, yeah, I'll write a bash script that says that, like leave your wife. So
let's learn it the right way. One of these days, here. Wow. So a little bit of background. So many years ago, in a distant galaxy, in my graduate project, some of you know I'm a musician. I've been a musician most of my life. If music paid more money than computer science, I would be there in computer science. But music is about patterns. It's all about patterns. And I was lucky enough to work. Okay. Yes. Why does it happen to me? Okay, so the world is composed of patterns, whether it's musical patterns. I also went to school for astrophysics, and I noticed that in cosmology, yes, um, there's plenty of patterns. Also, also there's in politics, in business, um, in everything. So the universe is made up of patterns. Okay, so patterns are everywhere, right? They're in astronomy, they're in music. We have certain musicians like, why was Elvis Presley popular? Well, it's not just, I mean, yeah, a great musician, but there was stuff that happened before him. He goes, wait a minute, why were the Beatles popular? Because there was something before them, the 50s. Why was Kurt Cobain popular? Well, there was the 80s stuff and that. So I said, wait a minute, there's a pattern to all this stuff, right? And when you look at astronomy and you see what a pulsar or a supernova, it's like a star is becoming, it's pulsing and it's becoming unstable. And then it explodes and it becomes a stable thing. Well, that's how IT is, right? We deal with certain technologies. It starts to build up cruft and then it gets this and all of a sudden, boom, and then there's Java or there's some other. So I said, wait a minute, these are all related. These are all related things. So and animals, and if you're a sports fan, like many of us here are sports fans, like you play sports, you're on a defense, you know the patterns of the offense and vice versa. So the word pattern comes up over and over and over again. This is very tricky. Okay. Let me remind myself to get a new laptop. Hold on a second. Okay, so it's all about patterns, but so machine learning, it's about looking at a data set and determining patterns and either predicting, like the weather, right? Like the Google search, predicting, or you're generating, like generative AI, generating text or generating images. Apologize for this. It doesn't like my two-finger swipe here. Come on. Okay. No. Okay. So what we're going to talk about is this big AI picture. So AI is is a machine that's simulating human intelligence. And you could argue whether humans are intelligent, but that's another thread. So the big picture is AI. So for many decades, we've had different technologies in AI. Back in the 80s, I had to deal with a lot of stuff when I worked for the New York Stock Exchange. We'd look at patterns of insider trading, and we used expert systems. So that's going back to the 80s when it was a very popular, AI was very popular back then. We programmed in Prolog back then. So now we have machine learning. So machine learning is where you're looking at patterns, right? Where you're not really programming the machine. The machine is sort of programmed by looking at patterns. And then a subset of machine learning is deep learning. And deep learning is where we have cloud computing, we have GPUs, we have a lot of modern computational resources, we have neural networks as an interesting data structure. So that's deep learning. But in the press, they rarely say deep learning. And the correct term is deep learning, but in a press you see machine learning. So I just want you to be aware that when you see that, they really mean deep learning technically. I mean, we're supposed to be the smart people on the planet, so we were supposed to know that the proper definitions, but everybody calls them machine learning. Now, inside of deep learning, there's two subsets. There's predictive and there's generative. So predictive has been around for like 15 years. Google search, the weather, right? That's been around for a long, long time. And, you know, some of these analysts, you know, you watch Bloomberg TV or something, and they say like, well, what happens if AI doesn't go anywhere? It's a bust. People are going to lose their money. No. Predictive AI has been around for 15 years. It's not going anywhere. There's many, many billions of dollars in predictive AI, right? Just Google alone, that's $100 billion just with Google in predictive AI. The predictive AI business is humongous. Nobody talks about it, but it's humongous. But in generative AI is the new kid on the block, and it's quite trendy. In terms of business, it's quite small. Now, over time, it'll probably match predictive, but right now it's fairly small. So I have Duke there, or Vizrek. So my colleague Zoran from the University of Serbia, we came up with a standard for predictive AI for visual recognition in Java. So because we noticed that many of the APIs to do AI in Java weren't Java. They were C, but it was used Java syntax. So you had like a method call that had like 25 parameters, like a C language thing. So it really wasn't Java. So we created a real Java API to do visual recognition. So there's a lot of colleges that are actually using our API to teach visual recognition in Java. But we're not going to talk about that. We're going to talk about generative AI. So that's the hot topic. And it's amazing. How many people have played around with generative AI? Okay, how many people have programmed with generative AI? Right. So I brought this up at Java conferences for the past few years, and it's people still haven't really programmed with the API. Everybody's used ChatGPT, right, or any one of the chatbots, the chatter robots, right? Which chatbot is an abbreviation for that, or contraction. But hardly anybody's been playing around with the API, and a lot of people have not been playing around with ChatGPT 4, the more powerful, right? So it's really interesting. Only 4% of the people that have tried ChatGPT use 4, and 4 is a way more powerful. So I thought that was interesting. I mean, we're at the start of a very, very long tail trend. But this is not like a year trend. This is like a 10, 15-year trend. And as I said last year, if you're a programmer, you have to know this stuff. And it's not just for generating code, right? Whenever you read an article for programming and AI, well, it's going to help you generate code. That's only this part of it. You're going to use AI for every aspect of your work life. It's whether checking emails, prioritizing bugs, writing reports. You're going to use it for everything, right? And it'll always have to be, think of it as like a super powerful IDE, right? It's going to be a good tool for you to be way, way, way more productive. So it's not going to take your job. Now, somebody that uses AI may take your job, but AI itself isn't. But you should learn this stuff. Okay. Now I'll talk about the underpinnings, not to dwell on it, because you'll see this diagram. Well, actually, these gentlemen that invented the first neural network back in 1943. Believe it or not, that is 3 years before the subroutine was invented. So that's how long ago it was. And I know I put in the email to everybody about, I'm going to tell you why skinny dipping held back neural networks. Well, these two gentlemen, their mentor was Norbert Wiener, who I showed a picture before. He's the one that said everything is composed of patterns. So they were students of his. McCullough was a little bit older than Walter Pitts. Walter Pitts was a genius, a mathematical genius. Warren was a partier. He was a party animal. So he used to, drink whiskey and go to bed at 4 a.m. He used to have these wild parties. And he used to invite Walter Pitts. And they had the lakeside place, and they used to go skinny dipping. Norbert Wiener's wife was a very conservative person. She didn't like that. So she said, I want you to cut off all connections with these people. And he did. And Walter Pitts got this because this was like one of my mentors, and he doesn't want me anymore. So he turned into an alcoholic, and he got despondent, and like he wanted to build a 3D neural network, and that never happened. So it slowed down the advance of neural networks. So that's just a little bit of trivia. It's a weird story, isn't it? Kind of a sad story. Sorry to bring everybody down. Okay. This is tricky. So here's the ubiquitous neural network diagram. Let me see if I can get rid of myself here. Okay. Hey, go away. Go away. Won't go away.
Click the little minimize.
So this diagram you see in every single, like, here's neural networks and machine learning. Now, there's only one reason I'm bringing this up. So this is the data structure that's typically used for machine learning. And actually even now there's even a variant that uses multiple neural networks. Like there's a couple language models that use several of these in collaboration. So each one of those little white boxes represents a connection and a weight. So you have text, you enter text in, say, ChatGPT, so coming in from the left, that's your input. And then what you're gonna do is feed a lot of text, right? If you're training this model, you're feeding a lot of text. And the model is gonna say, like, okay, what are the most probable words? And it's gonna figure out common paths. And you adjust the weights so that you force the data to go in that way. Right, that's what the weights are for these boxes. Think of it as like you have water going down a hill, and you want to make it go a certain way. Well, you dig holes, right? You dig the ditches deeper, so the water, you force the water to go one way or the other. So you're by adjusting the parameters, you let the text go a certain way. So each one of those boxes has a weight, and if the weight is positive, that means there's highly likely the next word will be this. And if it's a low number, it's not so likely. So you're building like a path, right? The most probable path. And it's a sparse matrix. I mean, we know what sparse matrices are. So there's a way of representing the sparse matrix. It's what's called the embedding layer or embedding vector. That's a representation of the middle part. So that I can give you, here's a bunch of numbers. That represents the middle part, as opposed to telling you this massive data structure where most of it is empty. It's just a representation. So keep that in mind. So we're going to come back to that later on. It says, come on. So the world changed in 2017 when Google invented the transformer architecture. So the transformer architecture is just a novel way of looking at words in sentences. So natural language processing has been around since the 40s. Right? It's been around for a long, long time. But Google has this really interesting technique of assigning weights to words. What words were more important than other words, and when a word was close to another word, what weight did it have? And also a really killer feature of this technology, of this technique, that it was parallelizable. And we know as programmers that's a good thing, because we know about threading, and we know about multi-core. So it was easily parallelizable. So before 2017, we didn't have this. But then as of 2017, the world changed. The ML world totally changed. And there's 1, 2, 3, 4, 5, 6, 7, 8 people on that paper. None of them work for Google anymore. They all have startup companies. They're not dummies. They don't work for Google anymore. But Google did patent the transformer architecture. Okay, they did patent it. I mean, big companies patent these things all the time. They don't do anything unless it comes up later on. Because I remember a story, a friend of mine was at Sun Microsystems, and they developed a piece of hardware, and they said, well, we patented it, and IBM is going to use it, so they'll have to pay us a lot of money. So they invited IBM to come in and talk about like how rich they're going to be. Like, oh, IBM's going to pay me a lot of money. So IBM lawyers come into the room, and they said, like, oh, that's interesting that patent you have. It's like, well, we have 25 patents on the thing that you're using. And they say, have a good day. So it's used as a weapon, right? So and IBM makes like 4 billion a year from patents. So what is an LLM? A large language model. Okay. It's not a search tool, right? You'll see on popular press, or you'll see people, the first thing they walk up to ChatGPT or Claude or Gemini from Google, what do? They type in a question. It is not a search tool. That's a mistake. It is not a search tool. Can it be used with a search tool? Yeah, of course. Can you build something that has search and LLMs? Yeah, of course, of course. But by itself, it is not. It is a probabilistic tool, right? You teach it patterns, language patterns, right? You teach it language patterns, and it will come up with most probable completion of that pattern. It completes the pattern that you prompted it with. That's why there's terms like prompt and completion. You prompt it, and it completes the pattern for you. That's where those words come from. So don't think of it as like, I'm going to search, it's going to give me all this information. Well, no, not think of it what it is. It's a probabilistic tool. It's a different tool that you're used to. In IT, we're not used to probable output, right? Your boss wants something. I want that information right now. The user wants it. We're not used to this. This is a brand new technology and new technique. Normally, we're programmed. We have input, we give it algorithms and code, and we get output, right? That's been like that for like decades. This is different. It's like we have input, we know what we want for the output, right? We know what we want. This is generally what we want. What's the middle? You're asking the machine, give me the middle part. And that's what this is doing. Come up with the model that generates this. So it's different than normal IT. It's good and bad. I mean, a lot of businesses don't want probable answers, right? It could be quite dangerous. Like, it's like, I didn't expect that answer, right? So we have to be careful. So what you should do, go up to ChatGPT or any one of the chatbots. Roses are red, violets are. That's a prompt. And then ChatGPT comes back with blue. Why did it come back with blue? Right, it's most probable. So it went through all the text, right? Because it's trained on internet data. And that's probably the most probable thing. It's a very like, it didn't say violet or say roses and violets are, purple. It said blue because that's the most common thing. And that's the next line it was being sweet to me. So it said that. That's how you should think of LLMs. It doesn't like my fingers. Okay. So when you write a prompt, you're steering the LLM, right? When you write a prompt, you're steering the LLM to give you what you want. So if you're good at steering, at the prompt steering, then you can get better results. Okay. So here's another thing that I typed in. So I typed in, here's Lionel Messi. Messi lines up the kick with his magical left foot. He shoots and then the language model comes back and says, oh, he scores, because that's most likely what would happen with Lionel Messi, since he's the best soccer player, football player in the world. I said soccer. So it completed my prompt. That's how you should think of an LLM, not to come up like, what is Java, right? Okay, so all of these LLM services, and for example, OpenAI has a really nice set of REST APIs. They have a Python, obviously a Python API, they have a JavaScript API, and then they have REST APIs for everything else. So the REST APIs are stateless. So that's important. The REST APIs are stateless. They don't save anything. Your conversation, once you disconnect from the REST call, there's no context. It's stateless. We know what stateless means, right? And in the chatbot on the left, that's another type of application that's also using the API. That's also stateless. But wait a minute. ChatGPT knows what I said in the previous line. So how does it know that when I use a stateless API? Keep that thought in mind, because we'll talk about that in a few slides. But remember, it's a stateless API. whether you use it from a server side or what's that device? It's called, was it a Humane, whatever. It's a AI device, the little guy. It's a little button that you wear. Anyway, is it Humane? Yeah, I think it's called Humane. We're gonna see like everything's gonna have AI in it. Okay, so I wrote this little curl script to use the API because it's just easy to look at. So you get an API key like you normally do for any REST call, and you log into OpenAI, you create an account, and you create an API. It's a long gobbledygook string, right? You just stuff it into the script. And here there's an endpoint. So here's the REST endpoint for chat completions. And you say, I want JSON output. Here's the API key up here. And there's a little language that you send to OpenAI, and they all have something like this. And the language is that, okay, there's keywords like, what model do you want? So OpenAI has ChatGPT 3.5, they have 4, they have 4 Turbo, they have a whole bunch of them. So you specify the model, and then there's messages. Well, what are the messages? Well, here's a message. Like, give me a Java program that displays hello world. And I asked for JSON, so I got back JSON. And in red is the Java program. So that's what you get back. That's how easy it is. It's very simple. So the API is not the hard part. We know about Java APIs, right? That's not the hard part. The hard part is understanding all the stuff. It's changing from slide to slide. That's what's hard. It does not like it. Keep. Oh, come on. Wow. All right. So stay there. So how many models are available? So what would you guess there are? How many models are there available right now? 500. Do I hear 600? 1,000. So as of a month ago, there's 500,000. Actually, if somebody wants to go to that link down the bottom, if you could see it, I bet there's 550,000 right now, right? Right. If you go to that huggingface.co models, there's probably 550, I would bet. That's a lot of models, right? It isn't just ChatGPT 3.5. There's a lot of them, and some of them are very specific, like medical models, right? For medicine or finance. How much? How many? Wow. Wow. So, as I said before, there's prompt techniques that you have to understand. Since the API is fairly easy. Okay, so this is challenging. Okay, so we've heard the term prompt engineering, and it's not engineering like we know and love, right? If you said prompt techniques, that's probably a better way of saying it, because it's not engineering. I mean, we know what's the definition of engineering. So engineering is not just solving a problem. You're solving a problem within a set of constraints. That's what engineering is, right? It's not just solving a problem. Well, this is prompt techniques. It's not engineering. Maybe the only engineering is that some LLMs have a what's called a context window. You can only send so many characters. Maybe in that sense it's engineering, but that's a stretch. Prompt techniques, right? Okay, so prompt engineering is a set of techniques that may give you the result you want. So they may give you the results you want. They may not give you the results you want. So we are in the early days. This is not a very mature thing. We're in the early days. I mean, sometimes you can think we're going from R&D into production these days. It's going so fast. So prompt techniques are techniques, English language techniques, that will help you get closer and closer to what you want. Right now it's an art. There's all kinds of templates and all kinds of other things to help you do this. You still have to track how well you do, right? You have to constantly track how well you do. So for example, you can have the best prompt techniques, but then here on the left, I have ChatGPT 3.5. And I said, what's the 7th word in the sentence? And the sentence is, Frank Recca is a software developer who lives in New York metropolitan area, right? So ChatGPT 3.5 gave me back software. Now the 7th word is who. I circle it in red, but it gave me back software. Why do you think it gave me back software? Anybody? Because how often is somebody asking for the 7th word? Maybe the first word is more popular, right? Or maybe the last word. If I said, give me the 13th word or give me the 36th word, that's probably highly unlikely. So it didn't know. That just took a guess. It just took a guess. And I tried with ChatGPT 4 and the same thing. So like, who is the 7th word? But it said, nope, it's developer. So it didn't. So that's the type of technology you're dealing with. Now, there are techniques like to solve this problem, you have to teach it. Please number the words in this sentence. Give them, 1 is this word, 2, number it. Now that you have it numbered, now give me the 7th word. And it's correct. So you have to train it. You have to constantly train it. So when you first get a result and it's not right away, so well, what's going on? It's bad technology. No, it's not trained. It's not, you didn't give it enough data. It didn't understand what are the likely paths. Right? That's what we're dealing with here. Okay. So just some techniques, start simple and add things as you go along. It's like writing a program. You start with simple and you build on top of that. And keep on making sure the simple things work. Okay. And always give it a lot of examples, and I'll talk about that. And it's interesting that LLMs, they're not good at negation. Like you say, don't do this, don't say this, don't do that. For some reason, and I'm still have to do some research, but they're not good at negation. And there's been a lot of papers on why. That's something I have to follow up on, but they're not good on that. You should tell it what to do, reinforce what it should be doing, not what it should not be doing. And you get better results. So there's a bunch of techniques now. There's no way in a short period of time to go over all of them. There's some basic ones. There's something called zero shot. Zero shot means I'm not going to give you any examples. I'm just going to ask you a question or give you a prompt, right? And I'm just giving it a prompt. Explain generative AI. Okay, I didn't give it examples. I said, here's 3 words. Go ahead. Okay. Now there's also few shot. Few shot means I'm going to give you a few examples. Let me give you a few examples, right? And here's some reviews. This is a fantastic product. If you see that, I'm considering out of 10, very positive. If you said no one responded to my emails for your product, give it a 0. Support was helpful, but the product broke, that's 3. So you're giving it examples. Here I gave it 4 examples. And the last line, still waiting for the product in the 6 weeks. What is the completion of that prompt? And ChatGPT says, well, it's probably a 2, negative. So you've given it examples. You've given it context, right? So that's why it came back with 2 negative, because you gave examples. Now, if I just asked that last line, it wouldn't know what to say because you didn't give it any practice, right? Any context, any examples. So that's called few shot. There's something called chain of thought where, let me explain how to solve this problem. I'll give you the algorithm, right? So Roger has 5 tennis balls. He buys 2 more cans of tennis balls, blah, blah, blah. It's like an SAT question, right? And here's the answer. Now, here's a new problem, and I want you to solve it. So you've given it the pattern on how to solve the problem. And it follows your pattern, and it will get you the right answer. Now, if I just asked it without giving an example, it would not give me the right answer. So it's all in how you train the model. And there's many, many other techniques, and that would take like an hour to go through those, but these are just some of the basic ones. So when you give a prompt to a language model, like for example, ChatGPT. ChatGPT is a web application, right? We know what web applications are. It's a web app. Now, when you give it a prompt, what's really happening under the hood is that you're not just giving the prompt to the server, to the LLM, but there's context, there's examples, and there's like output indicator. In other words, what format do you want this in? Do you want this in English? Do you want it in JSON? Do you want it as part of a Java program? So there's, and it's, you don't have to do this in order, but there's all kinds of tech papers on what you should put in the context and examples as part of your prompt. So under the hood, this stuff gets all glommed together with your prompt, and it gets sent to the language model. So you don't see that in the web app, but that's what's really happening, right? Because how did it know what I said in the previous sentence? Well, it doesn't. It's stateless. So what happens is that it took the answer, the original prompt, it took the answer that I gave to the prompt, saved that, attached that to your new prompt, send the whole thing. So it saves the context for you. It's stateless, but it has to stay someplace. So it saved it in like a little array. So here you go. There's a buffer that goes along with it. And then over time, this thing gets bigger and bigger and bigger because the context, just like a human conversation, the context gets bigger and bigger. More and more data has to be sent over to the language model. That's how it knows the previous sentence you were talking about baseball or something, or cooking. That's how it knows. Okay, so OpenAI is the big, it's the big player in the space. Although Anthropic, I've been playing with Anthropic Claude. The Claude is giving me some really good answers instead of ChatGPT. Okay, so OpenAI has all kinds of APIs, and they're actually a lot of fun to play around with. I mean, there's the completion, the chat APIs, there's vision APIs, there's text to speech and speech to text, a lot of cool APIs. Now, the bottom two, we're going to talk about toward the end, probably in 20 minutes from now, 10 minutes from now. That's really a little more advanced, but that's what you need to understand your documents, your private documents. Okay, so there's the API, there's the reference. That link will take you to the OpenAI APIs. It's just like any REST API from anything that we've done to get the weather, or right, there's all the thousands of APIs out there. That's the page to get the information. So it's fairly simple. Okay. And I just wrote this in a curl script because it's easy to show you. Like, for example, here's the endpoint, right? Here's the key that you have someplace. And here's this little language that you have, write a clever joke about Java programmers. And then here's a system message telling it how to behave. So by default, when you use ChatGPT, the system message is, I believe you are a helpful assistant. That's the string that's sent as a system message. But you could change that, right? You could say you're an obnoxious manager. And at the bottom, I said, here's some other parameters which we'll talk about. Oh, at most, only give me 50 tokens or 50 words at the end. Give me 3 completions. You can ask for more than 1 completion. You can give me a bunch of them, and maybe I'll pick the best one. Or maybe you send that to another LLM. You pick the best one out of those, right? You can use multiple LLMs. Okay. And here's the little playground. Like, we're very familiar with REST playgrounds where you can test out an API. They have a REST playground too. It's called the OpenAI playground. It's not rocket science. It's pretty straightforward. Okay. Here's what everyone's waiting for. The Java API. And I'm going forward and going backwards. Okay. So finally. So I think Python is really good if you're a data scientist, or if you're really interested in learning about this stuff, and there's a lot of libraries. It's a great language to learn machine learning, right? But we're all Java programmers. There's at least 12 million of us, right? And we want the Java API. Okay. So when I first learned this a year ago, ChatGPT was 3.0. So it was a REST API. So I thought, like, how hard can it be? It's a REST API. I mean, I've done this millions of times. So I built a little wrapper around ChatGPT 3.0. It's worked great, fantastic. Then they came up with 3.5. All my code broke. Everything broke. What they did is that they changed the endpoint to something really weird without telling anybody. And the language that you send, they changed this mini language they sent. So my whole application just broke. And I thought, like, okay, well, that means I have to redo what I did. and I didn't want to do it. I didn't want to do it anymore. It's like, and then they're gonna come up with 4, and it's like, I don't want to do this. This is like, I want to work on my application. I don't want to worry about the low level stuff. So if you're a senior programmer, what's the first thing you think about? Where can I get somebody that's done this already? Right? That's the definition. Every junior programmer said, like, let me write it. The senior programmers, where can I get it? Right? So I went around and said, okay, what's the best API? There's tons of them on GitHub. So there's a link. That's an important link. So you should clone that repo. So in my opinion, that's the best Java API. And he's done a really, really good job. So I use his API, and it's very simple. The first page of this presentation, that was his code. So he did a great job, and he's covered, as OpenAI has come up with more and more APIs, he continues to cover them with the Java wrapper. So he does a very good job. So that's something you should be quite aware of. Okay, so for example, this is it. This is how you do a completion in Java. And this is how easy it is, right? You get the OpenAI key from OpenAI, or that's pretty straightforward. You stuff that into this OpenAI service. So you make a connection, and then, okay, I want to use this model, and I could have said ChatGPT 3.5 or something. Here's a prompt. I want 3 completions. I only want 10 words back because maybe I'm doing development. I don't want a lot of words because you have to pay for it, right? So just give me a few of them. Temperature, I'll talk about in a second. And then it said build, and then give me the answers. That's it. That's how easy it is. And here's another example. And this one, I was changing the system message, right? Because I told you before, there's system messages, user messages. So I want ChatGPT to behave like a funny comedian with answers, and not like a helpful assistant. And I said, how should I learn Java? And you get back some humorous answers. It's less than a page of code. It's very, very straightforward. Okay. So is that clear for everybody? Okay. So if you learn this stuff, this is, I guess, why you and I teach, Barry. It's like you learn this sequentially. It's like, oh, it just makes perfect sense, right? It's not rocket science. So this is what I was talking about for the chatbot. The chatbot is using a stateless API. So how does it know about state? It keeps it. Somebody has to do it. It's not magic, right? So what happens is over time, this message is in context. So the prompt plus the answer that you get back to the LLM, plus your prompt gets attached, and then the new one gets sent, and then that gets sent, and it just gets bigger and bigger and bigger. So context or state is sent every time. That's how it knows what you said the previous sentence or previous communication. So context is sent along with that. Okay. So everybody with me so far, right? Okay. So that's how it works. But then how do I get the chatbot to understand my documents? Because it doesn't. So like ChatGPT is trained on the basic internet, right? Wikipedia, the New York Times, and probably why the New York Times is suing them, and other data. But most companies have their own data, and they're not giving their data to OpenAI, especially after the way OpenAI behaved a month ago. I don't trust that company. It's like, well, we're all leaving. We don't like it here. We're all leaving. See you. So I'm not going to trust that company. So, but how do I use a chatbot? How do I build a chatbot with my documentation, either inside the company or outside? How do I do that? Okay, let's talk about that. Oh. So there are several ways to get an LLM to understand your documents. There's several ways. Let's start at the bottom. You could be one of those people that knows how to create a language model. Very low level. There's probably a handful of people on the planet that can do this. So probably not, right? Maybe you're at the next level up. Well, I can use, maybe Barry, you built an LLM. Maybe I can use your LLM. I could train it on all the data I have. Maybe I have financial data, but I have to be a data scientist. I have to be an expert in statistics. I have to, be careful about legal things. So there's a lot of stuff have to be worried about. Probably not. I don't do that. The next level up is fine tuning. So maybe I take an existing model, right? So a foundational model, whether it's built on the internet or it's based on medical information, or like Bloomberg has financial information. I'll just take that and I just want to tweak it a little bit. I want to fine tune it. Well, that's a possibility, okay? But I still have to know about data science and statistics. You know, it's not for the average person. You have to be really good with data. So let's start from the top. So we learned about prompt techniques. So that's pretty cool. That works sometimes, but there's chance of hallucination. Like we saw, I didn't even know how to count, right? And then right below that, there's another type of prompt technique called retrieval augmented generation. And I put it in green. That reduces so-called hallucinations, which I think is a bad word. It should be, I think delusion is a better word. So that's a prompt technique, but it's a pretty clever prompt technique. So it will reduce hallucination, but it requires a database. But we're all programmers. We know what databases are, right? So that's interesting. So of all these, you're typically not doing these two, right? And you're probably doing one of these. You know, you might be at a company that, you know, we're going to build our own, or we're going to fine tune it specifically for finance or for something, you know, for e-commerce or something. Now this is what everybody calls no code, right? Everyone says, oh, we're going to do no code. That's this up here. Whenever you see somebody saying no code, you should laugh. It's not going to happen. You know, maybe 10 years from now it might happen. This stuff takes a long time to go through companies, right? There's a lot of non-technical things like legal things that people have to worry about before they put this into production. This is interesting. So that reduces hallucination and it uses my documents. That's pretty cool. So maybe I should look at that. Wow. Remind me to bring my mouse next time. Okay. So prompt techniques are okay, but there's hallucinations. So the foundation model, the base model, is not always up to date. Right? It's not always up to date. Why? Because it's expensive. It's expensive, and you're doing damage to the climate. You know, you're doing damage to the planet for you're generating heat, right? So it's expensive, and you need expertise. So you typically don't do that every day. There's usually cutoff points, and I think like if you pay a lot of money, if you pay like ChatGPT 4.5 Turbo is up to date, I think as of last month, but you have to pay a lot of money to use it. So it's not always up to date. It's better if I kept my docs up to date, then I'm in control, right? I don't have to rely on a third party. Okay. And when you're ever getting information from a chatbot, you should know where it got the data from. Right? And most people are not data scientists. I mean, when ML first came out, there was rushing to be a data scientist. And I had many students, I said, you know what? Some of you are never, ever, 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 ever going to be, you're not going to be a data scientist. I mean, everybody has specialties in life. You're probably not going to be a data scientist. Right? You can't be an expert in everything. Just don't get me started on full stack developer. The myth of the full stack developer. Okay, sorry. I apologize to the internet. I apologize. Okay, so here's RAG. So RAG is based on a paper, believe it or not, from Facebook. Something good came from Facebook. So this paper came out that called this new prompt technique, retrieval augmented generation. So it's a prompt technique. Now that diagram board had green and that slightly orange color. I purposely kept in those colors. The green colors up top means the neural network weights were not touched. The bottom three, the neural network weights were touched, were changed. That's why I had them two different colors. And of course, this is based on how people have conversations. So there's a paper, I think that came out like 10 years before this from Google, said like, here's how conversations typically happen and what you do about context. There's a whole theory of conversation, believe it or not, the theory of conversation. This is based upon that. So that also came from Google. How humans behave. This is how humans are supposed to talk anyway, right? Okay. So what this does is that when you give it a prompt, you don't just give it the prompt or some examples, but you give it some context. Like, I want you to answer, but I have my documents that I have stored someplace that in an enterprise repository, and I want to find similar documents and now answer the question based upon that context. But I don't want to give OpenAI my docs. Who does? Nobody wants to do that. You can do that once, I guess. So RAG is giving your prompt additional context. But what is that context? Well, you're going to save the context in a database. Okay, so here's the basic RAG architecture. So you start with the user. Sorry, Barry. Start with the user, and the user has a prompt, right? And then you're going to say, okay, what's the prompt? Let me find out, based upon that prompt, what's similar in this database? What's similar in this database? When I get similar data, I'm going to get that data, I'm going to glom that together with the prompt, and then send that to the language model. Right? So I'm going to look in the database, what's similar, and then send the whole thing to the language model. And we'll come to this part in a second. That's basically what RAG architecture is. You're looking for related data in your database, and then you take in that data and you say, give me the top 10 similar. Take that, attach that to here. So you append all that to this big chunk of text, and you send the whole thing to the language model. So this prompt becomes quite large. You know, when I used to work at Google, we had 10 pages. The prompts were like 10 pages of text. And you have to remember that somebody has to pay for this. You know, if you're one user, it's not bad, but if you have 1 million users, it's quite expensive. So that's what a basic RAG architecture is. And then you store all your text files and scraping the web and PDFs and whatever other data you have, Word docs and Google Docs, you store that all in there. That's the basic RAG architecture. Anybody have any questions about that? Yes.
The task of finding similar data in a database of potentially unrelated documents, isn't that a problem that's best suited for an LLM?
Well, yes and no. So
recommendation engines are one of the simplest uses of AI today. Like, you go onto Amazon and people who bought this thing also bought this thing. That's recommendation. Isn't
exactly
this a form of recommendation?
You're 100% right. So recommendation engines use what's called a vector database, use embeddings. And I'm going to cover that in a few minutes. That's a good intro into that. Recommendation engines, summarization engines, they use vector databases, which I'll explain in a second. Yes, bye. Okay, so I'll cover that. Yeah. Yes.
Just one other thing to add is that the cost of updating the vector database is much lower than updating the LLM. And because you have a pipeline of data that might be continuous, like constant PDFs, right?
Yes.
It's more effective.
Right. It's easier from a maintenance and cost point of view to keep the vector database up to date. Right. Right. Instead of the LLM. Because if you want to build your own foundation model, it is expensive. Quite expensive. Now that's the basic RAG architecture. So it reduces hallucinations, right? And you have context that you send along to the model. So it's not going to give you a wild answer based upon general internet information. It's going to give you answers based upon the documents that you send. Okay. So you're in control of the data. And this could be a fairly complicated database system that's feeding things on a continual basis, right? It's not just a database you decide to load it up. It could be a formal database system. Okay. And since it's a database, you can store where the data came from, like metadata. Like this data came from this document, and here's the date of the document. So you have metadata associated with the data. So whenever you see results, I want to see, well, give me a reference for that. Where did that come from? Like what document? Or maybe it was a transcription from a YouTube, or it was an MP3 that was transcribed. Give me the citation. That's very important. When you're looking for information, you want citations. Okay. So that's the thing in purple. You're glomming everything together. You're sending it off to the language model. So that's the basic RAG architecture. But in reality, if you work for an enterprise, there's a lot of other things you have to worry about. So that's why I said basic RAG architecture. But if you work for an enterprise and you don't have lawyers looking at this or compliance looking at this, whereas an answer may bring down your company. If you get the wrong answer to a certain user, it can bring down your company. You better have legal to check out the possibilities here. Is the data not biased? If you're trying to figure out, do I want to give a mortgage to a couple, and like if the data is biased a certain way, you can be in trouble, right? So you want clean data. Maybe it's you don't have to be a data scientist. I used to tell my students, you could be a data engineer. Data engineering is a huge occupation in the future because everything is around data, right? Data is the food for the language models, right? What retrieval technique do you use in the vector database? How do you version the embedding? So how do you version prompts? You have prompts and you have completions. Maybe some of them are good, some of them are bad. So you say, I'm going to try a different prompt. Well, you want to make sure you knew about the other prompt because it might be bad. I want to track that was a bad one. And I got a good completion with a bad. So you have to track versions, constantly do that. You can't just throw them away, right? You have to be very formal about this. How do you prevent hallucinations? How do you abstract the language model? Because I'm using ChatGPT now. I might use Anthropic tomorrow. I might use Mistral the next week. So how do you abstract that? How do you audit that in case somebody comes knocking at your door and says, I want to tell me why you got that answer, or else I'm going to sue you. So the things in red are things you have to worry about.
So how do you know that you're not giving your vector database information to OpenAI?
And that's a good question. I'm going to cover that right now. So, but my point is that there are other things to worry about. These are traditional IT things. Yes.
How do you translate, like say, you were giving an example of calculating like tennis balls, right? How do you translate that, like, so that you can calculate it, you can based on some other parameters that you give in?
So I'm going to cover that right now.
Oh.
So embedding vectors and similarity, because I want to find in my database what are the similar things. There's that magic word similar. What does similar mean, right? So let's find out what that means. Okay. Swipe. Okay. So we're going to talk about the red square. We're talking about, I think, Sai, you had asked about chunking strategy. We'll talk about that too. So a RAG system, RAG system has to find similar content, right? So it looks at the original prompt that the user typed in. I want to find things that are similar to that in my database. But how do I find similar? What does that mean? How do we determine that? But that's the context, right? If I can find the similar things, that's the context. That's what I want to send. So let's consider an example. Let's look at something very simple that right? Like my laptop. so let's say we all love music, right? And let's say we have a bunch of songs and we want to find similar songs. Which songs are similar to which other songs? So let's go through a little example. So one way of saying, is Taylor Swift's song, is that similar to the Queen Bohemian Rhapsody? Is that similar to Green Day's Basket Case? Well, how do I find similarity? Well, I can use something, let's try something very simple. How about beats per minute? I have a song like this. So let's use beats per minute just as one parameter. So if I use just beats per minute, and I looked them up. And here I have like, these two, the BB King Thrills Gun and the Queen's Bohemian Rhapsody. If I subtract, this was 144 beats per minute, this one's 91. If I subtract, the distance is a similarity, right? That's how similar they are. That's one parameter. So I can take this one and subtract that, and that's a similarity. But if you look at things like, here's like, classic jazz song, and here's like pop punk. They're close here, but are they really close? Right? Is Ella Fitzgerald pop punk? So no, this doesn't make sense. So beats per minute, it's a good start, right? It's one parameter, but that's not the best. So let's try another parameter. We have beats per minute. Now let's add like whether something is jazz or rock, is slow or fast. So we put them in graphs like Bohemian Rhapsody. It's a little bit faster, but it's close to Taylor Swift. But they're not similar, by the way. There's Metallica that's up here. We have Miles Davis over here. So if we find their XY coordinates and I find the distance is how similar they are, right? Pretty simple, but it's certainly not the perfect thing. So those are two parameters. Then you can add like, is something major key, minor key? There's something is a transposition. Are there certain lyrics? So you can add more and more parameters. It could be dozens and dozens of parameters. This is what Spotify does, right? They look at all these different parameters, and then Spotify actually looks at the waveform, and it does a Fourier analysis on the actual waveform, and then it calculates that, and then use that as additional parameters. So we have n dimensions, and here I just talked about 2 dimensions, but typically there's hundreds, if not thousands, of dimensions. So since humans can only see in best case 3 dimensions, right? We can't visualize something that's like 100 dimensions or 200 unless you're from a different planet out there and you can visualize this. So for words, there is a way of looking at words and coming up with how close they are, how similar they are. There's something called an embedding vector. So if you remember from like the 3rd slide of this presentation, there was the middle part of the neural network was a representation of the sparse matrix that was just an array of floating point numbers. That's that. It's a representation of the middle part of the neural network that represents the sparse matrix. Now, for words, there's a whole bunch of ways that we can create this vector. And OpenAI has a service. You get, give me the so-called embedding for hello world. And it gives you back 1,536 floating point numbers, single precision numbers. By the way, it turns out machine learning only needs single precision. It doesn't need double precision. So it gives you back that string, and you give it another string, it will give you a different vector that represents that string. You can give it a long string. You can give it a paragraph. It will give you the same 1,536, but different numbers. And what you do is you take this embedding vector, and you take another one, and you want to find similarity. You want to find how close these 2 vectors are, right? Just like I did with music, except now we have 1,536, not just 2. And here's OpenAI's embedding service, and you just Theo's API is really nice. Here's the model, and I get the data. Someplace I give it the text, and I have actually IntelliJ running. So you get the text, and it gives you back the embedding vector. Yes. That's a very good question. Is there a standard for embedding? There are common ones. There's like word2vec is one. I think OpenAI is based on that. There's a small handful of them. Just like for music, there's only a small handful of them. You can come up with your own, right? So there's no like one standard. But there's
But you want to use the ones that's compatible with.
I'm sorry, say that again?
No way to just create a database of one embedding and then say, now I want to send this to Llama.
Yes, that's a good. So you do not mix embedding vectors, right? So you don't want your vector database to have a bunch of embedding vectors from different places. It's just, you're not going to get consistent results.
And you can't update on the site, you actually have to call their API to get a vector.
So you don't have to use OpenAI. If you're using OpenAI's LLM, you do not have to use their embeddings. You can use someone else's embedding. Just don't mix that embedding with OpenAI's embedding in the same database.
Would you calculate it on your own without?
Oh, yeah, of course. Yeah. So I think in two slides, I'll show you if I created my own.
But it needs to be compatible with with the LLM.
It has to be consistent.
Okay, it doesn't
Yeah.
have to be. Okay.
Yeah,
Oh, yeah, that's right.
it has to be
No,
consistent.
it makes sense.
Okay, so what was this? So I just created a wrapper. Oh, I know why. I created a wrapper around the previous slide because I wanted to call this later so I could save space on the slide. That's okay. So now that we have embedding vectors, right? So that these long vectors, how do we find similarity, right? Because I said we define similar things. Well, what does similar mean? Well, okay. I need to find similarity between two vectors. And if you remember from the university, I remember my teacher, we're going, there's two matrices and you have to, multiply these two matrices, get that from that row, and multiply this, put those over here. It was never explained to me why we need to learn this. It's like, why am I learning this? This doesn't make any sense. This is the reason why. It helps
Thank you, Frank.
figure out, it helps you figure out how similar two things are. Okay. So while that looks a little complicated, it actually isn't. It's there. I wrote the code for it. I mean, that's how easy it was. I mean, it's like when you learn like in school like integration or differentiation. It's the notation that bothers you, right? So it's really quite simple. So here's my high level method, and it calls magnitude there and dot product there. Yeah, dot product there. So actually pretty simple. And here's an example. Like, give me one string, give me another string, and I'm gonna call the method I just had in the previous slide, and then the similarity. And if the similarity, if I remember, if it's close to 1, that means they're very similar. If it's 0, close to 0, that means they're perpendicular. That means they're not similar. So that's how you can tell. So you compare it against a bunch of words and it's a bunch of strings and say, if I get it between 0 and 0.8, they're very similar. So give me those. If it's below 4, forget about those. I don't care about those. So that's how you determine similarity. Okay. Now you don't need a database. You don't need a vector database. You can do this on your own, like I just did. The previous 2 slides, I did it myself, right? But a database is more than just those 3 methods, right? I need CRUD functionality, table management. I need administration. I need security. Let me use a database to do this. I don't want to do this myself. So to do this, I need a database. So the type of database that handles these long lists of floating point numbers is called a vector database. So a vector database is good at handling long streams of floating point numbers, and it knows how to calculate similarity. So you didn't have to do the methods that I had. As a matter of fact, there's several other methods, several other types of calculations that you can do. I just use cosine similarity. There's 2 or 3 other ones. Actually, there's probably 5 of them. So there's vector database. Now, vector database, like I said, it stores a string and it stores the embedding vector for that string. And what you should also store, you should store metadata. Like, where did that string come from? What document it came from? What was the timestamp? Right? So then later on, when you show the results to the user, it's like, well, here's the result, here's a completion, but it came from this Word doc, it came from this PowerPoint, it came from this MP3 on this date. So you can tell the user more information. So you store that in the vector database. So that's why I use a vector database. And there's a small number of them. And some of the conventional database systems now handle vector things, like Postgres now handles this stuff. I'm using Milvus, since out of all of them, I tried their Java APIs. They're all run by Python programmers. It's only APIs, even though that says Java, doesn't feel like Java. And Milvus was the least offensive one, so I picked that one. And I still argue with those guys all the time. No exceptions. They don't have Java exceptions. Any of the code is like, ugh. Okay. So now here's what we talked about before, the chunking strategy. So what do you store in the vector database? So you can store text, but do I store a sentence? Do I store part of a sentence? Do I store a paragraph? Do I store HTML? So you have to decide chunking strategy. Now, you might say, like, well, what's the best one? It depends what you're doing. Like anything computer science, the answer is it depends. Right? It depends. Do you want something very granular, or do you want something wide? The wide answer. So this is early days. This is very, very early days. So you have to play around a chunking strategy. Sentences, paragraphs, markdown, HTML, all these different things. You have to try them. So that's why it's called a chunking strategy, or sometimes this, how you parse things strategy. And in my example, I use text. I use sentences, and I can stuck in text, or I can scrape a web page or PDF. What else did I add? I added. I can load in the sentence. You can type in a sentence. I added the MP3 because I used their speech to text transcription, and then I took the transcription and then I parsed the sentence and fed that in there. I had a lot of fun for about 2 weeks doing all this. Right. So you have to come up with a chunking strategy. There's a lot of trial and error. Again, we are early days, right? Okay. And here's code just to parse a string into sentences. So I can get a large string, and it's going to give me back a list of sentences. So this is my foundation. This is what I wrote first. So then I can give it any string. I can scrape a web page and give all that text to this, and I got back a list of sentences. Then what do? I stuff that into the vector database. Well, I get the embedding for those sentences, then I store it into the vector database. So that's the heart of my code. So we're all Java programmers, right? So you can parse a sentence into a list of sentences. That took me 50 minutes to figure out the code before. Now you can store them in a database, right? And then you can find similar strings, because I taught you how to find similar strings. And then vector databases have an API call to do that. So what's next? Well, the next thing that's next is that we're Java programmers. We've been doing this for decades, right? How do you parse a text string or CSV or a website? We've been doing this for decades. So now's the time. Now we're starting to put these things into maybe early production, or maybe test, not quite full production, but to test. We know how to do this, right? So pick a vector database. We know there's plenty of libraries to parse spreadsheet. You could parse a spreadsheet, or parse a CSV into strings. We know how to do this, and then store that into the vector database, right? So with that, I'll show some quick demos. But if somebody has a question, will I try my luck at getting my IntelliJ working? Any questions? No questions? That means I did either a very, very good job or very, very bad job. Okay. If I make this larger. Okay, this is embeddings. What does this one do? Okay, let me run this.
How successful we are in creating your vector database?
How successful?
Successful, yes.
I
mean,
so
it requires some skill, right?
yeah, oh yeah, sure. And then you have to have people that are
how do
looking.
you assess your skill?
You have to get the
completion,
What's the criteria? I mean, criterion or criteria.
it depends on the use case, right?
Okay.
What is the,
How do you know that your use case has been, I don't know, processed correctly?
that's why you have to hire data scientists and look at the results, right? And then
So
you have
it's
to
a big
evaluate.
question still.
Yeah, no, it depends on the use case. It's an excellent question.
Very
How do you
tricky.
evaluate how
Yeah,
well the system did?
Tricky.
Right. No, it's a very good question. So let's see here.
Is that another question?
Question? Yes. Sorry.
So my question was, in terms of the model determining the answer or the response that it has to come up with, how does a model decide as to when can it say, hey, I don't know this information, versus you also said it hallucinates. So how does it decide whether it knows or it just goes into that hallucination mode in a way?
Because remember, this is probabilistic, right? So it looks for the most probable answer. And it might not, it'll give you an answer, right? Now, if you get an answer like, I don't know the answer, that means somebody like me put in a system message like, if you have probability below this number, say you don't know the answer, right? So it doesn't know by itself. It's well, data dependent, right? So
that's why it's better at saying, like, if you ask ChatGPT, for example, what happened in Jan 2024, it will say, I don't know. So somebody has actually put in logic to say, hey, if the year is greater than something like this, then just go with this default response.
well, it follows the path. What's most likely, right? It says like if you ask it doesn't know about specific. It's not a search engine. It's just completing text. Just think about it from that. It's not giving you back information. It's completing text based upon patterns that it knows. That may be information or it might not be information. It's completing the most probable path through a bunch of text. So you have to get past this thing that it's giving me bad information. It's not an information tool. It's giving you probable text strings. That's the key thing. I mean, we have to know this, right? As developers, this is how it works. Now, can you build an information tool that uses this? Yes, of course. But that's in conjunction with something else. You might have a user type in something, and then based upon that, you say, oh, there's some websites I should go to. Go there, scrape those, and get embeddings for those, and now compare that, all do this while the user's typing that in, right? Okay, so let me, if you can see that.
Calculations, right? You were saying, is that done as part of the vector, like when you're generating the embeddings, or it happens in LLM? Like say,
so this is what I'm showing you right now. So when you a string, you're not storing the string by itself in the vector database. You're storing the string plus the embedding.
I meant like the calculations, right? Like so you say
The similarity calculation.
yeah, like so you have some number, and then how do you do that? Like you want to extract that as a, like say, parameter,
right?
And that there can be any substitutions in that, and then you do calculations based.
So what you do is that, so you have strings, and I'm just typing them in, but you can get that from a website or something. Can you see that? So if I type this in, and I'm going to use the OpenAI embedding service to give me back embedding, and hopefully the internet works here. So it gives me back all these numbers. So like I said, 1,536. And I might do it to another string. And I store these both in the database. I store the string embedding vector, string embedding vector. Then to determine similarity, I could do it manually like I did it in my code, or usually vector databases have a call. So like find out how these are similar. So it's going to look at that embedding vector, not the string, the embedding vector and this embedding vector, and you pass those vectors and say, find out how similar they are. And you get back a number. And if that number is close to 1, they're similar. If it's close to 0, they're not similar. So that's the vector database doing that. Did that answer?
Like those, let's say the numbers are like taken as the parameters, and then we compare the rest of the text.
Yeah, so it's typically the API says, get me a vector. So I give like a this vector, and I give a pointer, a reference to another vector, to the vector database, and say, tell me the similarity.
like my code did, right? That's all it's doing.
In that example you had, it's the idea that you're going to have your documents and there will be associated vector to each document. Or
Exactly.
a string in a document,
Well, it
or-
depends. If you break it up by sentences, then it's per sentence. There's an embedding vector per sentence.
Depending on the chunking you choose, yeah?
Right. So then you get the user prompt, right? And you say like, okay, what's similar to this? And you look in the vector database. First of all, back up a little bit. You have a string, like I typed in my name, right? Get that string, get the embedding vector. I now have these numbers. Now take that number. Now I ask the vector database based upon the embedding vector, give me the top 10 most similar things. And it gives me back those strings, right? Because it's a database.
The reason for all this, what you're doing to get those vectors is to send the top 10 as a context to the ChatGPT, correct?
Exactly right. Exactly. You're sending it context, additional context.
So these vectors are only for the reason of generating the top 10 answers from your
To
database.
find similarities.
So if you try to find something what is similar to your question you're going to send to ChatGPT.
Precisely.
And you need to find the top 10 of those things in your database and you're attaching it to the context and then you're going to get better answers.
Bingo.
Right?
That's exactly right.
Okay.
That's exactly right.
Frank, we have a question here, and I think you answered it already, but it's from the YouTube, and it says, do we have to use the same embedding as the LLM used? I think you said
No,
it has to be
right.
compatible, or consistent, not
Right.
necessarily the same.
Don't switch embedding services inside a vector database. Use one all the time. You just want to be consistent. Doesn't make sense, right? You don't want to mix the notion of similarity varies between these two. Why would you mix them? Right? You want to see why you want to be consistent. So that's getting embedding. I can compare embedding. So you run this guy. So this is comparing two. So here I'm speaking on GenAI and Java, and then GenAI and Java work together. Java work well together, and I'm calling my own code that I showed you a few slides ago, and then it spits out the similarity, and it's still running. Okay, whoops. So 0.795. So they're somewhat similar. Those two strings are somewhat similar. Now, what if I typed in something completely, let's see, what would I put here? We like pizza. Pizza. Okay. Let's see. It's very low, right? 0.14, 0.46. So they're not that similar. So you see how that works? Yes, question.
One more question. So the whole idea was here to not to have your own LLM because it's going to be costly and problematic to update, yeah? But the second element you said was you don't want to send too much your private data or basically expose all your documents to the OpenAI or others external service. But you still do send those data, isn't it? Because
Yes.
you're sending them as a context. So over time, you're going to send more and more and more. More questions you send, more data you send.
That's true. So
you're going to end up with sending everything maybe.
So, but they're not storing it. So
How
OpenAI,
do you know?
they use, that's a good question. How do we don't know, right?
Like
It's just like a website says, we guarantee we won't sell your data.
Yeah. Exactly. That's the point.
Like, what's this in New York? Come on.
So more you use it, more of your own data you're going to send.
Yes.
Until you will send all.
Well, I'm not sure about that. You send similar to the user. Yes.
But is it true that you're going to send more and more over
That you're
time
100%. You're 100% right. ChatGPT used to save your data, used to train on your data until people complained about that. So now they don't use your data. They don't use your data to train. Now what they do with that. So to get around that, instead of using OpenAI, you would use an LLM that sits on-prem.
Right.
Right. And there's many open source ones. I didn't want to use the open source one because I'm having a hard enough time changing the slides with my little laptop. but it takes a fairly hefty machine to run it. The question back there.
I'll be there in a sec.
Can you reverse engineer from an embedding? Can you get back to a string? Because otherwise you don't, if you can't, then you don't have to worry about it.
That's a good question. I'm not sure. I don't know the answer to that, but I'm not sure I would trust like a company like OpenAI with my embeddings if you could, because effectively it's a distillation of your knowledge, right?
Right.
So I wouldn't give them that. Right? It's a distillation of your documents. Question?
So on that point, you send the embeddings to the LLM.
Yep.
What is the result that you get back? Do you go back to your vector database to actually reconstruct your sentence?
Right. So you go to OpenAI or embedding service, whatever it is, you get the vector, right? I happen to use OpenAI, but you could use some other service. Once you have that, then you store that in a database, right? So there's like two phases. You're storing things in the database. Okay, forget about the user prompt. You're storing stuff you're getting embedding vectors, and you're storing in a database. That's a separate process. Like the data engineering team is doing that, right? But then the people writing the application is that I'm getting the prompt. I get the embedding vector for that prompt. That look at the databases that the database team worked on. I'm going to find a similar ones based upon embedding vector. What are the strings associated with the embedding vector? Take those, give me the top 5, give me those. I'm going to stick that with the user prompt, throw that to the LLM, and give me back a completion. And it's going to give you a better result because it has context. Yes.
You had 2 strings and it took a couple of seconds to determine how similar they were. So if you had a database with 1 million rows in it for 1 million different things, which is pretty conservative because you're storing documents and you have a row per sentence. Then somebody types a prompt, you have to match it. You have to do a similarity check against every row in the database. So
that's why you use a real database, not my code.
but how is the database going to do it any faster? This is
no. So these are professional database people writing with they have indices.
Right, but an index wouldn't help because you've got to do the similarity with the vector that you got from the prompt, which is a new vector. You can't pre-compute it.
Well, we can pre-compute some of the elements.
No, you're computing the similarity between this new vector, which didn't exist before because it comes from the prompt, against all of these old vectors. You've got to compute that similarity.
This is an argument about.
Now there are mechanisms.
Don't know the algorithms, involved, so we can just assume that there are algorithms.
So there are ways to optimize that. Yeah, right. There's a reason why there's a bunch of companies trying to go public and with their own special sauce, make them go faster, right?
If you go to a conference and go to an exhibition space, there will be 15 vector databases shown there.
Right. I mean, there's discussions on Discord about speeding up similarity searches all the time. Question?
One question. So when you build the context where you have multiple documents, does the order of those documents matter? And is there any weight associated to them? Like maybe
the order of documents going to the database?
Yeah. To build the context, let's say the older one will decay faster and the newer one have higher weight or something like that.
I don't know the answer to that question. Whether you put it recent docs have better.
And so similarity does not equal, it's like wordplay. Similarity does not equal relevance to the question. So one technique is to get those lists of texts that came back from the similarity search, go to an LLM and say, given this question, order them by relevance. And so somewhere deep in the brain of this, it is prioritizing what comes first in that list. And this paper from Microsoft, they're readable, right? They're kind of oddly approachable, these papers, is exactly that point. That's an amazing question.
Yeah. There's also something related that the context window is that the size of the buffer that you send, right? Pardon me? It's constantly growing, but you have a limit. That there's certain models that have certain limits, right? And you have to pay for this. So I have a spreadsheet that if you have few users, that's not bad. If you have 1,000 users, that's you get in there. If you have 1 million users or several 100,000 users, it's quite expensive, right? So you have to be careful of that. And Gemini from Google has, I think their context limit is 1 million, but it remains to be seen whether that's good or not. I mean, is that useful? because I saw a paper from some students at Stanford, like depends where the data is in your context, where the valuable data is. It before, front, or is it in the back, or is it in the middle? So this is early days. As I said before, we're going from R&D to production. It's like almost like on a daily basis. So this is early days. We're still learning all about this stuff, but it's an excellent question. So I'm trying to just my last demo. Okay, make sure I kill that. Kill everything. Kill everything. Okay. Just do without a mouse. Okay, let's see. Oh, on second thought, my database just crashed. So never mind. Milvis just crashed on me. So, any last questions? I have not had experience with Postgres, the vector database, although I have a friend that works there keeps on reminding me to use it. But I plan using it. Yes, question back there?
I'm curious how good it is.
Yeah.
And they seem very similar. Is it what would be you consider the difference?
I'm sorry, I missed the last part.
What's the difference between generative and predictive? It's not obvious because you get something back from Google, it kind of looks like what comes back from ChatGPT.
What's the difference between generative and predictive? Oh, okay. So predictive is that you're looking at data and you're picking a few, like the weather. That's not generative. You're not generating the weather.
Giving back what somebody else has said as opposed to
you're looking at a model data and you're looking at patterns and you're making a prediction about the future. You're not generating, right? You're not generating anything. Where generative is the word generative. You're generating text or generating an image or you're generating, music. That's why it's called predictive. But I mean, we've been using it. The weather has been around for it uses predictive AI. Well, it's generating a model, but it's right. It's not generating the weather, right? It's like text. We're generating text.
The weather's been around for billions.
Yeah, for billions of years. Yes. Sorry. One last question. Two last questions. No. This is fun stuff, and it's again, it's early days, and you should all learn this because it's going to be part of your daily life. And it's not just for generating code, or it's going to be about checking how you check email, how you prioritize bugs, how you deal with the reports, how you do that. Use it for everything, not just generating code, but use it for everything. It's very valuable. Yes. So there are some advantages with Python. So right now, Java has a hard time connecting to C libraries, right? So Project Panama is it's still early days for Project Panama, but that's the solution. Make it easy because it used to be GenAI. GenAI was the painful way. I remember doing this at Lehman Brothers. It was a painful way of connecting C libraries to Java. It was a major headache. So Project Panama gets rid of that. So you connect the C libraries very easily. It's still maturing very easily, and that's the solution. So and then Python is not object-oriented, so you don't have to learn object-oriented first to do Python. That's why it's easier to teach. That's why instructors like to teach it better rather than Java. I don't have to teach object-oriented programming. It's easy. But things are changing. So the next version of Java, actually, no, I think it's 22 yesterday. Is it like you don't need a class?
There's a default class, unnamed class.
Right, but you can teach Java without creating a class. So it's getting very similar to teaching Python or how to use Python. But there's so many libraries out there for ML and Python, so it's hard to compare it right now. But we haven't put everything into production. And what's Java good for? Java is very good for production. So our time is coming. Right? So I'm way over time. So thank you everybody for coming. I'll see you next time.
The people on YouTube, thank you very much. Everyone here, the raffle, if you won to participate in the raffle,